An overview of the system in its current state. Here we have the system, and behind me on my bed are our output channels, and up on this monitor is our display. We'll start with the first of about 6 or 7 scripts that I've written. This is just very simple. It displays the prompt. It tells you that it's going to turn on light cue if it'll ever focus. Press the enter key and you get what it tells you. So we get light cue 1, then it tells us there's a blackout next, so when we push it again we get a blackout. Light cue 2, so we know we're going to get a different sequence, so in this case it's the lights that weren't illuminated last time, and another blackout. So as we move down to script 2, which would be much better if we could see. You can see that you can put into the console and have it spit out anything that you want it to say. So in this case, we have notes, so that we can keep track of what needs to be done and when. So in this case, it's telling us that light cue 1 is for scene 1 and act 1. So when we press enter key, it's going to light up behind us. We can see that light cue 2 is going to go right after the actor exits the stage. So when we press it, it changes, and then we have another blackout. And then it tells us it's the end of the show. Number 3 is automated. There's very little reason to have an automated sequence of lights during a live theatrical performance, because you always want to be in control of this phone has very little memory. You always want to be in control of what's currently on the stage, so you never make things automated, except in this case where if you want to do something that's a very quick effect and you don't want to be mashing your go key, you can sequence the entire thing like such. And as you can see, it has a very, very quick refresh rate, and you could even have them move faster than that. Now, this system was designed originally to only control lights, but it was just so incredibly easy to include sound that I decided I would do the same, because the target audience for this is going to be a lot of small theaters, and this could also serve to be the same key that you control your sound effects and your music with. You can have one single key to control both of them with, especially if it's a very small theater and you're short on staff or you're just short on equipment. So in this case, it's going to start up our script, and it's actually going to turn on this light bulb, and as soon as we press the play button, it's going to trigger that and a sound effect at the same time. So in this case, it could have been a light bulb breaking, because that's what we have right here, or a lamp falling over. I'm going to jump to another video because I know it's going to cut me short. I'll be right back. This next one demos music. So this is going to demo a few things. First is going to be one of the lights is going to attempt to fade up as the music starts playing. The music is going to play, and then we can cause the music to fade out and the light at any time we choose, because again, you want everything to be completely in control. However, when you press this, if you need to end the song prematurely, when you press it, it'll fade out instead of cutting out, so it seems intentional. So we're going to begin the show, and we're going to press 1, and we're going to press our go button, and we're going to start. So at any time we can press the go button and the music will fade out whenever we want. So I'm going to do it right now. A very small addition to the last program shown is the ability to trigger a video. A lot of theaters will have a video projection system, and since we already have a display coming out, we can take advantage of it. So if we wanted to trigger a video, we could do so very, very easily, and it could be used. Of course, the video can be as long as you want, and of course you can stop it at any time. last but not least is just a real quick GUI that I came up with, and this is just to control each individual channel and all if you so wish. So we can turn on channel 1, and we can turn on channel 5, let's say, or we can turn them all off, and we can turn them all on. So it gives you complete control without having to type something into a command line every time you want to access it. Now that you've seen what the system is currently capable of, I'm going to go into more detail about how all this is accomplished. We'll start at the heart of the system, the Raspberry Pi. You can think of it like a normal home computer. The computer itself doesn't have a keyboard, mouse, or monitor. We have to provide those things so we can interact with the system. The Raspberry Pi works the same way. The only difference is its price and size. The Raspberry Pi has one more addition compared to a normal computer, however. It has what are known as GPIO pins, small square contact pins found on the side of the board. These pins can be turned on and off by using code on the Pi, and can create a loop when one end of the circuit is connected to one of the dedicated ground pins. In total, the board has 40 pins, but some, such as ground, have dedicated uses and can't be used freely. The electricity that comes from these pins isn't enough to turn on a light bulb, however. That's why we are using a relay board to control AC voltage coming from a wall outlet. A relay board is essentially a collection of switches that control the electricity flowing from them. These switches can be controlled by sending an electrical signal from the Raspberry Pi. We are using 9 pins in total to communicate with our relay board, 8 output pins and 1 ground pin. When one of these pins is energized, it completes the circuit along the ground pin and informs the board which channel we are attempting to control. The relay board knows that when we energize the wire coming from pin 11 and connecting to channel 1, that we want to turn channel 1 on by closing the circuit. AC power is provided from a wall outlet. AC plugs typically have 3 prongs. One is called hot, one is called neutral, and the last is ground. For our purposes, we will only be using 2, since light bulbs don't have a ground pin. The relays have 1 wire of hot going into them, and a wire for hot coming out of them. When the relay is switched on, the electricity will flow from one wire, through the relay, and to the other wire connecting to the light bulb. This is how we are able to control each bulb. Neutral is always connected, since we only have to break the flow of electricity in one place to switch the circuit off. I'd also like to briefly summarize the events of my learning journey. The first thing to arrive was the relay board and its power supply. After cutting off the adapter and stripping the wires, I realized that the wire coloring might not be accurate. To determine which side was positive and which side was negative, I used a tool called a multimeter. Using a multimeter, I was able to determine which side of the wire was positive and which side was negative. This allowed me to connect the correct sides to the relay board. The next thing to arrive was the Raspberry Pi. As you can see, it's no larger than a credit card. Its small form factor makes it a very popular choice in home projects. I stripped 9 different wires, connected them to the Pi's GPIO pins, and screwed them into the relay board. After all this was done, it was ready for testing. I connected the output to a display and powered everything on. After confirming that everything was wired correctly, I installed it in a temporary enclosure made out of a recycled orange crate. I quickly began coding. The following video is one of the very first tests I ever ran with the system. It went far better than I could have imagined for a first test. The orange crate had served its purpose, but it was time to move it to a more permanent structure. I chose a plastic enclosure with a lid and ample room for all of the electronics required. I grabbed a sheet of plywood, cut it down to size, and mounted all the electronics on it. The next thing to do was to organize the wires so that they wouldn't get in the way. Once everything was mounted and organized, it was time to begin the last step, wiring everything to the extension cord outlets. The work was slow and tedious, trying to weave wires in between each other. But it paid off, and the outcome was tidy and efficient.
The only thing left to do was to test the system to make sure everything had been wired correctly and begin coding more advanced features. After a few hours of planning and coding, I was able to create the demo you saw earlier. Nothing felt more rewarding than seeing all of the parts of this project come together. I'd like to sincerely thank everyone at Griptape for making my learning journey possible. If it wasn't for you guys, none of this would have happened. I wish you all the best of luck with future challenges, and I look forward to working with you guys again. Thank you so much for your time, and take care.